Okay, we're moving into our triangle unit. We're going to be talking about right triangles during this unit. Today, to introduce ourselves, we're learning about the Pythagorean theorem. Your learning target, you are going to be able to apply properties of the Pythagorean theorem. Okay? Here it is. Given any right triangle, the sum of the legs is equal, the square of the sum of the legs is equal to the square of the hypotenuse. A squared plus B squared equals C squared. And notice here I said must be a right triangle. I was just going to write that. So make sure you put an exclamation mark or something by that. It has to be a right triangle. I want you to make your right angle on this triangle. Some kids get genuinely confused. What's the A? What's the B? What's the C? A and B always make up the legs. Well, what do I mean by legs? Legs are the shortest distance. Leg, leg. They make the right triangle. So A and B are always the legs, and they always make the right angle. So then this A squared plus B squared will equal C squared. So we can do the converse. Converse means backwards, working backwards. If I give you 3 dimensions, I say do these dimensions create a right triangle. Can I make a right triangle out of the dimensions given? You cannot make a right triangle unless it satisfies Pythagorean theorem. A squared plus B squared must be C squared. So what I do is I find the square of each. And then I see if the sum of the small squares equals the bigger square. So I see if the sum of the smaller squares equals the bigger square. Maybe put square. That's me satisfying A squared plus B squared equals C squared. A and B are the smaller dimensions. Hypotenuse connects the 2 legs. Hypotenuse is C. C is always the longest. C is always the longest dimension. Okay, so A and B make the right triangle. C is whatever that longest dimension is. So your learning target today, you are going to be given numbers and you're going to have to tell me, do these numbers create a right triangle? So given the numbers 3, 4, and 5, can I make a right triangle that has these dimensions? Well, which one is my C? 5. It's the longest one. So that's my C. And then it doesn't matter what you choose as your A and B. Because addition is commutative, you can flip it around. So I'll say, does 3 squared plus 4 squared equal 5 squared? That's what I'm checking. I'm doing the converse. Does 9 plus 16 equal 25? 25 does equal 25. So yes, they create a right triangle. Okay, so again, the biggest thing you need to know is how can you tell what A and B are and C? C is always the longest dimension. A and B are the 2 smaller ones, and it doesn't matter which ones you use. So 1, 7, and 9. Can I make a right triangle that has these dimensions? Which one is C? 9. So then I don't care which one is A and B. So does 1 squared plus 7 squared equal 9 squared? Does 1 plus 49 equal 81? No. 50 does not equal 81. No, you can't. Not very formal, but I didn't want to write right triangle. Okay? Our next learning objective with Pythagorean's theorem is to solve for missing side lengths. Again, you must know what makes up the right angle. A and B are whatever make up the right angle. You have to know that. A and B are whatever makes up the right angle, and C is what connects them. C is opposite of the right angle. So we're going to solve, we're going to apply the properties of Pythagorean's theorem to solve for missing side lengths. So A squared plus B squared equals C squared. My right angle is right there. Okay, does it matter if I do 2 or 4 for my A and B? It doesn't matter what you choose for A and B. It doesn't, because commutative property of addition tells us it's okay. So I'm just going to say 2 squared plus 4 squared equals C squared. Which is 4 plus 16 equals C squared. Now you're going to see me do something here, and it's just my personal preference. C squared equals 20. What did I do? I flipped it. Why do you think I flipped it?
So the letters on the
Yeah, I like my letters on the left-hand side, and you don't need to. It's just my personal preference. The letter I like on the left. So notice what I did. I knew that I was going to have to get rid of to isolate C, so I wanted C on the left. So I just flipped it and combined my 4 and 16. What's the opposite of squaring? Square root. C equals the square root of 20. And leave it like that. Actually, I want to check your homework to see how your homework... Nah, your homework actually calculates it. Darn it.
No, it's not.
Yeah, but it's only a button. It's okay. It's just a button you push. So I'm going to... It's not half. It's square root. So I'm asking myself, what times itself is 20? This is an irrational number. So I'm hitting the square root of 20 equals 4.5. Estimated. Okay. Now, I have an A and I don't have my B, but I have my hypotenuse. I'm going to have to do some good algebra here. So, plug in what you know into Pythagorean's theorem. Oh, oofed up. 4 squared plus B squared equals 36 squared. Do you agree with those numbers? Well, I need you to agree. C is 36, and then you square it. A is 4 squared. 16 plus B squared equals, oh, calculator, you're going to love them today, 1296. Now, you can't take the square root yet. What do I need to move away? I need to move that 16. How am I going to move a positive 16? So then I have B squared equals 1296 minus 16 is 1280. 1280. How do you get rid of the square? So B is the square root of 1280. 35.8 rounded, right? B equals 35.8. Now another one. Notice that this one, you have to know that most kids think you use this strategy where you're given the numbers, add them up, take the square root. But this second example showed you had to use some algebra to get the letter alone, the variable alone. Okay, so 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. I'm going to flip a root. C squared equals 25. Right? C equals the square root of 25. C equals 5. Now I want to summarize. That's all I want to go through today. Let me just refresh your memory. Learning objective number 1, you're given dimensions, and I say, does this make a right triangle? And you have to see, does it satisfy Pythagorean's theorem? Remember, the biggest number is always C. So it's not always going to be A, B, C. It might be 4, 11, 7. C might be given to you in the middle, too. Okay, the biggest number is C. And then second learning objective was actually solving. So A and B always make the right angle. So I always add those sums. Sometimes you have to use algebra to isolate a variable. To get rid of a square, you take the square root. Your homework today, you have to actually calculate what the square root is.